This is the first draft of the midterm report. So when we are analyzing buildings, we have to write a report. This is not a design course. We are not, the final goal of this is not to submit nice panels or posters of the, it's just to analyze a building, and we have to create a report, a written report, can be Word or PowerPoint or whatever. And then we have to insert screenshots or tables or graphics that come from other software. But the goal is to write a report and to draw conclusions and to give clients some recommendations about what we can do in terms of energy efficiency of the building. So first, we have to write a report. Second, and we have to start. And what is the starting point? Description of the building. So we have to take screenshots of the building, 3D plan section, so showing spaces, define orientation, and window to wall ratio. Okay. So we have a building. So you have been working with a building like this, and we have to define the building. So the first thing we should do is to take a screenshot of the building like that. So I'm going to prepare a PowerPoint. Okay, so the first thing is the cover page with the title, with your name on it. Then the second page will be the table of contents. And the first is the introduction of the building. Or now then the introduction, the description of the building. Okay, so for the description of the building, what do we have to do? We have 3 plans and sections showing spaces. Since usually you don't show spaces in when you are describing the building, but in this course I need to know that you know how to deal with spaces. So it's important that first we have a 3D view. Okay, so that's the first 3D view of the building. I'm going to save it in pictures, okay. And this is it. The description of the building, and you have to add some text. It's not just drawings, but the description includes some text. So you can insert a text box. And what kind of text? At least we need location. We need use of the building. It can be office or an office building, or, well, it's not a residential building, but the use of the building. And then we need the floor area. The floor area, if you just select the floor, we have here the area of the building. It's in this case, it's 661 square feet. Okay, so we need the floor area. And what else? Then in the description of the building, this can be the first page, just a 3D view, and then basic information, location, use of the building, and the floor area. Then we have to keep working on the description of the building. But in this case, we can upload, or we can show plans. Okay, so remember that here we have the plans. Dimensions would be nice we don't need a section. Okay, so let's do it a little. So when we are working with a Revit file, we can have all these auxiliary things, the section, the reference planes. But when we are working with a presentation, then the first thing we have to do is to probably duplicate view. And this is level 1 for the presentation. Okay, so on this level 1, we don't want to show this. We have to hide this. We don't want to show reference planes. We just want to see the architecture itself. And we need the spaces. Okay, so somehow you have to highlight the spaces. And we can show relevant information about this. We have the area, the total area of the floor, but I think we should show also the area of the spaces itself. So how can we do that? We can do this with rooms, or I think in space, if we analyze and we use space tag. In annotation, mechanical, well, probably if I select this, or I can do this with room. Okay, so I can, rooms work better because in room, sometimes it's redundant having spaces in room. We need spaces for the, to deal with heating loads because rooms don't work. But I think rooms work better with this. So here we have office 1, the same names, try to use the same names that we are using for the spaces. Okay, so if this is the space, remember that we had space names. This is office 1, okay? That was office 2, so that room will be office 2. And that was the meeting room, I think. Yes, so that's the meeting room. And that was space. Okay, let's name that space like office 3 or yeah. And that room will be office 3. Okay, then these names, we have 1, 2, 3. I think it's even better. Look at this. If you click on the tag and then you edit type, these are the room tags. If you edit type, we have show volume. Volume is not relevant. Okay, let's click show room number. It doesn't matter, but at least you have to show the area. Okay, so let's see what it looks like. It's quite okay. So that's if you double click here, you have the room tag or the properties of the room tag. So that's the room number. And here you have the volume and the area. So I would do this because I want to show the volume and I want to show the area. Then load it into the project, overwrite the existing version. And here we have this. Okay, so I don't want the room number because I have a name. So it doesn't make, well, maybe it makes sense. But I want to show the room number, the volume, and the area. The text size, it's huge. Probably I can solve this by changing the area, no, by changing the scale. You see that if I have a very small scale, like 1/8, the text seems too big. But if I change this to 1/4, the text, it's better. Okay. So I think that's the right way to show it. And with this, I have the spaces highlighted, so I know that you know how to deal with spaces. And we have information about the use of the building. If it's office, it can be a healthcare building, whatever. But depending on that, you have to go to buildings. Remember that if we go select the space, and here in space type, we go to building. And here we have different options. We have a lot of options. Okay, so we do have office buildings. Here we have office enclosed, office, open plan, and open plan office. We don't have partitions. Here we do have partitions. So if this is an office building, it will be enclosed. We have lobbies, living hotels, pharmacies, a lot of things. Okay, but if we just select office enclosed, it doesn't mean that everything is perfect here, because look at the area per person. We agreed that the area per person was going to be 20. Okay, and the CFM, outdoor air per person, it's again 20. Remember that you have to change at least these two things. And then the outdoor air method, don't click by people and area. It's a maximum by people or by area. Because if you click by people and by area, you add up to outdoor air. Okay, so yeah, you add these two, to add up these two numbers. We don't want to do it. Okay, so I want to do the maximum by people and by area. Sometimes we have requirements. If we go to the ARCH360, in some spaces, usually it's with people, but usually it's 20 CFM per person or 1 CFM per square foot, or it's not one, it's point something CFM per square foot, like this. So we have two requirements and we have to select always the maximum. Okay, so in this case, I select maximum per people and area. And if you want here, we can type 0. So we make sure that the maximum per person or per area is this one, because this one is 0. Yep. And then the rest of the things we can keep the same, but at least the area per person and the CFM per person, it's something that you have to change in all these spaces. Okay. So you can select any type and it works. For example, it's useful for the schedule, because if you go to the space type and if you go to the power schedule or the occupancy schedule, you have here a common office occupancy. So the common office occupancy, it starts at 6 a.m. Then we have a peak, then people go to have lunch, and then another something like that. Okay, so we don't have to think about the schedule. So that's why selecting type, it's good, but it's not enough, especially for the area per person or for all these, or for the outdoor air per person. Okay. Those are things that you can show in the, so why not? Okay, so if we are selecting or we are describing the building, we can also select the schedule settings. And this is something that we can copy and paste. Okay, so I don't know where, but we can show the building and we can show the schedule. So this is relevant information, because if your client, oh, the schedule, no, in this office we work from midnight until 7 p.m. and then we go to sleep. Okay, but at least here you have a proposal of what the schedule of this building is. So we have this. You have to show the plan of the building. And if we are working with the plan of the building, we have to show plan sections, elevations. Well, if you show the 3D view, or if you show different 3D views, we don't have to show elevations. But at least the planning section, I need one of the sections because I need to see that the spaces are, because sometimes the space can do something like that, and that's a terrible mistake. Okay, so I want to make sure that your spaces are working well. So here is the same. We are going to use the same scale for everything. It's 1/4. In the section is not relevant, and get used to this duplicate view and just create a section 1 for the presentation. And we don't need levels. Section. And let me do this. I think I need another section here. Okay, so if I need another section, I go to level 1. I don't go to level 1 presentation because I want another section here. So go architecture, view, section, and I need a section in this direction here. This is section 2. And in section 2, I duplicate. This is section 2 presentation. And I change the scale 1/4. I want to hide in view all these category. I don't need the plane and I don't need this section. But what I do is to show the spaces. Okay, so in visibility graphics, I have to go to space. And here I have to click these two. And here I have the spaces. Okay. And by doing this, it's important that the scale is the same. Okay, so try to line up this. There you go. So make sure that things are lined up and they have the same scale. Yes.
Oh, we're going to model space tag or showing those sections.
The space tags or the colors? Let me see. We can use one of the presentation features of Revit. Okay, so we can go to sheets. We can right click, create a new one. And if we are working with PowerPoint, okay, or if we're working with Word, well, it depends. Imagine that we want to work with PowerPoint and we want to create like a presentation 11 by 17 so that we can print it out in an 11 by 17 size. So we can always change the design, and I can select the slide size, custom, and the width can be 17 and the height can be 11. Okay, A landscape, okay. And now we have an 11 by 17 format. It was smaller, so I can either make the drawings bigger or I can include more things. So if we have an 11 by 17, if we do the same thing with Revit, I can click OK here. The first thing we have to do is to double click here and change everything. Okay, so let's get rid of all these title blocks. And now I'm going to create an 11 by 17. If you select here, you can type here 17 inches. No, 17 feet, no, 17 inches. And if you click there, we can type 11 inches. Okay, so this is the 11 by 17. I load it into the project. Override the existing version. And here I have a sheet 11 by 17. And now I can drag the level 1 presentation. Before doing this, I have to level 1 presentation. I have to hide this in view. And showing the crop region, I have to adjust the crop region to this size. Okay, and then hide the crop region. And now I can do it. I can go to the sheet, drag this one, and now it has a good size. And here we have information about the drawing. So this is level 1 presentation and the scale. If we want to insert now the section 2 presentation, it's here. But again, before doing that, I have to go to the section 2. I have to adjust the crop region. Then hide it. Now go back to this, drag section 2 presentation. And that's very useful because you see that when they are lined up, we find the dashed line, and now we make sure that they are lined up. Okay. And again, try to line up the title blocks because everything looks nicer when everything's lined up. And finally, I will drag the section 1 presentation. Again, get rid of this. Hide the crop region. Come here in section 1. It's there. Again, they are lined up. So now the 3 drawings have the same scale. They are lined up. It looks nicer. Okay, so those are small details that make a presentation more professional. And now we can either print it out, probably for the final version. If we want a more quality, high quality graphics, we will have to print it out as a PDF, and then we can deal with that. For this draft, I'm going to do this. I'm going to just select the image. By the way, this is not lined up. Okay, there you go. So now select the image. And instead of doing this, I'm going to insert that picture There you go. Okay. If I'm describing now the spaces, maybe that's a good way to place the schedule. Okay, so this is, that matters. Okay, we submit something with all the drawings at the same scale, everything is lined up, everything is clear, we have enough information, the report will look more more professional. But that's why I want you to submit the draft first, and then we will, I'll help you improve it. Okay. So here we have 3D views. Here we have basic information about the building. When it comes to the 3D views, if you don't want to show elevations, probably we can show different parts of the building. This is the northwest side of the building. The other one was the southeast. Okay, so the same thing now. Okay, with these two pictures, we have plenty of information because we have the orientation here, we have the sun, and we have 4 elevations of the building. The quality is not great, especially the shadows here. I don't know, there's a problem, but anyway, that's a draft. So that's the description of the building. Here you are describing the 3D volume and the facades, and here you are describing plan sections and spaces, and we have information about the volume and the square footage of each space. And here we have the schedule. So there's a lot of things in 2 slides. Okay, so we have the description of the building. And a window to wall ratio. Okay, so that's important, and it's basic information that we need here after the floor area. We need the window to floor, window to wall floor. Does it say window to wall ratio? Okay. So what does it mean? That's important because the first thing we found out last week that the area of windows matters. Okay, so it's something that creates a lot of especially cooling loads. If the windows are south or east or west oriented, in the north, it doesn't matter. But well, it matters in cooling, in heating. But for solar gains, having a lot of windows in the south, it's something relevant. So the window to wall ratio, it's the area of the window divided by the area of the wall. So how can we do that? Remember that we did something like that in Revit. Remember that we created schedules. Okay, so we had here the wall schedule and the window schedule. Okay, so the wall schedule, here we have the storefront. For us, storefront as are windows. Okay, so in this case, we have all this area. We have to add up all the exterior walls, 110, 76, 105, 372, 295. And if we are analyzing the window to wall ratio, these are the windows are here, and the walls are in the denominator. So the wall area is this. We have to add up all these numbers, and then the window area is all the curtain walls. So that's why we need to select the wall type, because if we have a curtain wall, it shows up in the wall schedule. It doesn't show up in the window schedule. Okay, so for the window schedule, we will have here a 196, 97, no, what, 7? 88. So that's the curtain wall. For us, those curtain walls are windows. And then we have windows, so we have to go to the window schedule. And remember that here we have 3 windows, say 6 by 3. So it's 3 windows times 18. Okay, so that's the total area of the windows. The curtain wall, curtain walls with glass, plus the window itself, and then the wall. We have to add up all these numbers that we have in the wall schedule. It's 110, 76. Uh, 105, 300. Plus, do not add the interior walls. Okay, so here we have interior walls, do not add those ones, and then we have 290. Okay, so you divide this like this, and here we have the window to wall area. We can have a number. Imagine that here we have 0.9. We multiply this by 100, so we have a 90% window to wall. I don't know how to make this stuff, but that's how we calculate the window to wall ratio, which is something very important. And in all the reports, this is the first number that they're looking at. If you have a very high window to wall ratio, the first thing that an expert will tell you, okay, can you reduce the area of windows? If you have a window to wall ratio very low, then you have to find for another solutions. Okay, but it's a very important number. And we have Revit. Is there a way to add all these walls up? I think so, but I haven't figured it out. But if you find a way to do it, that would be great. Okay, but I'm sure that there is a way to add up all the walls. But be careful, because when you have curtain walls, it's glass. For us, it's a window. Probably it's instead of wall to window to wall would be, it's a glass to wall ratio. Okay, but be careful, because by default in Revit, when we have a schedule, the curtain walls are within the wall schedule, not in the window schedule. Okay. So if you don't remember how we created the schedule, I'll do it again. You have to go to view. In view, we have these schedules here, and then quantities, and then we have to select a category. Well, activate everything, because, for example, if you want to create a schedule of spaces, which is useful, we have to use the mechanical template. Let's do that. So let's create a schedule for spaces. Okay, not specialty equipment. Schedule. Spaces. Okay. And what do we want from the spaces? We want the area for sure. We want the area per person. That's good. We need volume. We need the name. The number of people can be interesting. And we can have even the heat load values. Okay, so let's select all these and let's create the schedule. So we have 4 spaces. Here we have the area of the space. We have the name of the space. Probably the name should be the first. Here we have the volume, the area per person, the number of people. And here we have heating load values by space type. Well, this we will find this information in the report. It doesn't show up in the space schedule, but I think that's useful. Okay, because that information, it's something that we have to add in our report. So we can always, for example, if we are in this thing and we want to drag the space schedule, that's something very, very useful. Okay. Yeah, so I think we should do this, and then we can select the schedule of the building itself, but having this information about area per person, volume, the name of the space, and the number of people, I think it's something relevant that we can add here. Okay, what else? We're just describing the building. Okay, so we haven't started. Well, we do have started because all these are inputs that we need to get.
Would you want to see for the midterm, do you want to see what the building looks like, or it's more like just a basic generic building that we created the first time around?
What do you mean with the basic generic building?
So like when we first did the building, we just did generic walls, generic
Oh.
and everything, and then we did the solar analysis. So do you want to see like the gains from us actually not doing the building and putting all the.
No, we have to start with a building that meets the passive house standards. Okay, so we have we need R40 or more for walls, 50 for roofs, 20 for floors, triple glazing, low emissivity. So there is no point in designing a bad building and then, oh, if I meet the passive house standards, the building will be better for sure. I'm interested in what we did here. I'm interested in what we did with the walls. Okay, so you remember that for the first analysis, we have a lot of solar gains through the, and then we did something to reduce those solar gains.
So that would be.
Yeah, so that would be the improvement. Okay, but the passive house standards, we're going to, that's our starting point, the passive house standards, and now we're going to make it better. So we are far above the average architect that's okay, so let's meet the passive house standards. No, we take it for granted, okay? But then if you want, especially because there will be a moment, it's not mandatory yet in New England, but there will be a moment in which passive house standards will be mandatory, okay? So there is no point of, okay, let's design a building without and with passive house standards and compare it. There's no point. So let's do this. Let's design a good building first and let's improve it. And the way that we have to improve it is to analyze the solar heat gains, okay? So I want this, I want, so the first option should be like, like curtain walls. So use a huge amount of glass and then try to reduce the solar heat gains that we have in summer and the heating loads that we have in winter by changing, by dealing with the curtain wall. So you remember that we did different things here. Some of the panels, we made them opaque instead of transparent. And then we used shadows or louvers to do this, okay? Okay, let's continue. Energy analysis of the building. First analysis in Revit. We have to define the R value, walls, roof, triple glazing, I would say low emissivity too. And then we have to generate the first report with peak cooling and heating loads. Okay. And then the analysis of heating loads of the main spaces of the building. So we did that, and now you have to show me that you can deal with this. So if we edit type, we edit the structure, and you show me the layers and the R value. Okay, so the R value in this case, if it's a roof, it should be above 50. So you can take a screenshot of this. Okay, so that's the envelope description. And we have roofs, walls, and floors. So that's the roof. Then you have to show me the wall. Okay, so remember that this wall, the R value should be about 40. And finally, we need the floor. Okay, so we have the envelope description. We have roofs, walls, and then the floor. When it comes to the glass, the triple glazing, remember that we can, if I select the window itself and I edit type in the window, I have low emissivity triple glazing. Okay. And if I select the panel, the curtain wall panel, remember that I have to filter, and I want to select only the panels. And here in the type, you can select low emissivity and the solar heat gain coefficient. But the problem, I can specify this in Revit, but I need you to deal with real stuff. Okay, so in Windows, we need to work with the catalog. For this wall, I can make up the wall. So I can say, okay, this is the gypsum board, then an air chamber, then thermal insulation, then brick, then whatever. And it's something that doesn't work with the catalog, because if we use the right materials and we specify the materials, we can do that. But with the window, of course, I can specify that I have triple glazing and low emissivity and the solar heat gain coefficient, but I need to find a catalog. Okay, so I'm going to post a catalog on Canvas, but if you find so we need a catalog, a commercial one, with the U value and the solar heat gain coefficient. For example, we have this online glass U value. Let's see, what do we get here? No, but this is not a commercial catalog. Solar heat gain coefficient ratings for Windows, National Glass Catalog. Interesting. But this is going to be too much. Low emissivity glass. That's interesting. I'm going to copy this. But probably we have to go to a glass manufacturer. I think we have everything we need here, but it's too much. Well, here you see that we have information even about the drawings that we can create in our interlayer. Okay, so it's a very good catalog, but I think we have too much information. So what we need is just, let's go to Guardian. Glass technical data sheet. Probably this is what we need. There you go. Okay, so this is the kind of information that you need. I have selected Guardian because I think it's an English-based brand, Guardian Glass. So there, I think I have told you before, there are 4 or 5 glass manufacturers in the world. Then we have companies that assemble the glass that come from these companies. Okay, but Guardian, Pilkington, Saint-Gobain, and some Asian companies. So they are the ones that manufacture the glass itself, the raw material, and then there are companies that cut the glass panes, they put them together with the spacer and all that stuff, okay? Yep.
Is there any purpose to those sunshades, or are they just aesthetic?
This,
Yeah,
good question. There should be a purpose. But since they have this in this elevation, I think it's aesthetics. But I mean, you can do this if there was a south elevation, those elements should be horizontal. If there's an east and west elevation, those elements should be vertical. That's fine. And if there's a north elevation, they don't make any sense. So since we have here 2 different elevations with the same aesthetic thing, I think it's aesthetics. But it doesn't mean that you don't have to do it. Here, if you look at the south elevation, the curtain wall that we have here, we have something like that, but they are horizontal. So that helps. In this case, I don't think it helps. Okay. But what we do see is that this glass is not transparent at all. It's like a mirror. So that means that has a very low solar heat gain coefficient, probably because the cooling loads were so huge. Then the first thing they did was to reduce the solar heat gain coefficient. So probably this is 0.2, something like that, because it's not transparent at all.
is there a way to express that to have reflective glass?
The only way we have is if we go to edit type and we go to this, if we select solar heat gain coefficient of 0.2, that is a reflective glass.
Okay.
Does it show up in Revit as a reflective, as a mirror? That's another question. Probably you have to go to the material itself, not here, but you have to go to the if we go to manage materials, and if you select glass, okay, so you can create different kinds of glass, and then in appearance, you can deal with the reflectance. So does it work? Try, but we are not dealing with this. Okay, so for us, the solar heat gain coefficient is the parameter that works with the glass reflectance. Then how does it look like in a render? Probably if you change that reflectance, the Revit, well, probably it changes. Okay. It's a good question, but yeah, we're not designing a building, or we're not rendering a building. We're just analyzing the building. But anyway, we need something like that. You see that here we have double glazing. We don't have triple glazing. Okay, so we have to find a triple glazing catalog. And what do we need here? We need the solar heat gain coefficient. You see that these solar heat gain coefficients are very low. So we have up to 0.16 or 1.26. So this is very low. It's not transparent at all. So that's why in the cover page, we have this building, which is complete. It's like a mirror. Okay, so here we have another one that it's a little bit more transparent, but this one it's completely is reflecting all the light. So it's a mirror. So probably this is 0.4 solar heat gain coefficient, and this is 0.1 or 0.2. Okay, so we need this. We have the solar heat gain coefficient, and we have the U value. The argon or the air, that matters. It should not that much. Usually argon, it's a gas that has a lower thermal conductivity. So the U value should be better with argon than with air. You see that this is 0.2 and this is 0.23, or this is 0.24. Okay, so when we fill the cavity with argon, the U value goes down, which is better. Okay. So that's it. But those are the kind of things that we need. There is always, if you deal with the glass manufacturers, they're always trying to reduce the solar heat gain coefficient and increase the visible light transmittance. Okay, and they can do that. Glass, it's the glass industry has improved a lot over the last decades. And it's not only double glazing or triple glazing, it's the coatings. You see all these coatings, which are thin layers that they are added up to the glass itself. They can be transparent or they can be not as transparent, but they can deal with the solar heat gain coefficient and the visible light transmittance. So what is the goal for these companies? To reduce the solar heat gain coefficient, because that reduces the cooling loads, because solar heat gain is the amount of solar of heat coming from the sun that enters the building, and the visible light transmittance is the amount of light. So we have this solar radiation. We have part that is heat, another part that is light. So they are smart enough to create a coating that prevents heat from entering, but allows light to enter the building. How do they do it? Chemistry, and it's but this is their goal. Okay, so to increase the visible transmittance and to reduce the solar heat gain coefficient. But for us, for the thermal performance, if we want to add aesthetic values, then we have to look at the visible light transmittance. But for us, from the energy point of view, we need the U value and the solar heat gain coefficient. Okay. So here, this catalog that I have selected. Okay, so we have solar heat gain coefficients here that are around 0.6, 0.7. And they have a good U value. So something like that. Okay, so this is transparent, as we can see. So something like that will go well for our building. Okay, something that has a high solar heat gain coefficient and a low thermal conductivity, a low U value, sorry. Okay, so I'm going to post some of those. But when we are analyzing the glass, we need to take a screenshot of an actual catalog. And then we paste it here, and we have to highlight the element, the catalog, the glass that we are using. I don't know, in terms of the solar heat gain coefficient and the U value. If you think that this is a right if you think that this is the right one, we need something like that. And then you have to go to Revit. So if in Revit we have selected this triple glazing with the solar heat gain coefficient of 0.65, here we have the heat transfer coefficient U, it's 0.25. Okay. So I think the one that we found here. Yeah, so this is 0.27, it's not 0.25, but it's close enough. And the solar heat gain coefficient, it's 0.66. So that would be something similar to the glass that we have in Revit. Okay, but Revit has standard values, but they don't have the specific brand, the commercial catalog. So we need to find the commercial catalog that has the properties that we have assigned in Revit. Okay, so we are describing first the building, then we are describing the envelope, and for the envelope we have floors, roofs, walls, and we have the glass. Once we have this, then we have to run the first analysis, and we need the peak cooling and heating loads. Remember that we did this before. We had this report. Okay. We have the peak. This is cooling. So we have the total here. And somehow we have to summarize this report. It's a good thing to print this as a PDF. Let's do it. This is report 1. Nope. There's another printing option because I want to print that report. So probably it's here. If we print this as a PDF. Let's see what we get. Well, that might work. I think there's a way to print all the sheets at once, but I want you to modify that report. So how can we do it? Well, we can do it, but we don't have here the. Okay. Do you have the Adobe? Okay, so once we have printed out the report, we need to summarize it. And a good summary would be a summary of heating and cooling loads. So here we can have different spaces, space 1 or office 1 or space 2. Okay, so you have to type here the names that we have, 1, 2, 3, 4. And we might need here heating and cooling. Okay, so if for space 1, the total heating load is, we are in space 1 heating, the total heating load is negative 5,000. So you have to copy this here. Vaya. Copy. Okay, so that's the heating load. Units are important, so, but we can type the units. If we always have the same units, we can type the units for heating and for cooling there. So for space 1, the cooling heating load, we go to cooling. That's the figure. Copy. So that's it. Okay, so we need to create this summary of heating and cooling loads for all the spaces. And finally, we need the total. Okay, so for the total, we have to add up the heating loads and the cooling loads of all these spaces. Having that report is nice, but I think it's quite complicated because we don't have a summary. Probably there's a way to find that. It will be much better if we could. Here we have systems load summary, but nothing is there because we haven't dealt with systems yet. So is there a way to calculate everything we need here? Probably in the detail. Here we have cooling, heating. We have a lot of graphics, but there is too much information. So here we have a table of contents, annual building utility performance summary. Okay, so I'm sure that we can find that information in this report, but look at this. There are a lot of things that we don't need. Okay, so we don't have a summary, or maybe we do have a summary in Revit. They change this with every version, by the way. So it's very difficult to get used to it. System summary. Let's see. Time set point, outdoor air, minimum outdoor air, entire facility. I think it's much easier if we do this. If we go to the loads and we just copy and paste the heating and cooling loads, because that's what we need to understand what's going on. Okay, so I need to know what space is the most demanding in terms of energy, and I need to know if heating is more important than cooling or the other way around. Okay, so that would be the first heating and cooling loads. We have already done this, so I'm asking you to do the same, and you have to show me that you have the first analysis with some figures here, and then on the second analysis you can reduce the figure. But you have to reduce the figure that is the most important one. Okay, so in this case, if I have that space, heating it's 5,000, cooling it's 14,000. So you have to do something to address the cooling. Then, once we have reduced the cooling loads, we can address the heating loads. But the most important thing here was this. I think we did that analysis. We analyzed this a few weeks ago or last week. And if you remember, we found out that in this meeting room with a lot of glass, the most important thing was the cooling load of that space. And then we addressed that cooling load by changing the glass. We did something very ugly, which was just replacing all the curtain walls by an opaque wall and small windows. But I want you to do something else. Okay, so I want you to keep the aesthetics of the building, just replacing probably some of the transparent panels by some of opaque panels, and try to add shading devices to that in order to reduce the cooling load of those spaces. Okay. So this is the first analysis. We have to define everything. And then the second analysis, benchmark passive house. Well, our benchmark passive house is also the first analysis too. But we have to propose a solution to reduce the cooling loads due to window solar gains. So that's it. And then we have to analyze the heating and cooling loads of the main spaces of the building. So we need another summary of this. But here with the summary of the loads, that would be analysis 2. So you have to show me that you have reduced the heating and cooling loads from the first to the second analysis. And then conclusions. What have you done? So basically you need like a final slide of conclusions. And you have to let me know what you have done. The first analysis we had, the problem was this, I did that and I solved this. And probably the last part of the conclusions is the percentage of savings. The percentage of savings is, we can have the heating load first analysis. Let's say that it's 20,000 BTU hour. Then we have the heating load of the second analysis. So let's say that it's 16,000 BTU hours. So what's the percentage of savings? The percentage of savings is so what's the difference? The difference is 4,000. Divided by the value of the first analysis. So that would be 4,000 divided by 20,000. Okay, so this is 0.2. If we multiply this by 100, so that will be 20%. Now savings. Okay, savings. So that would be the last conclusion. First, you have to tell me what the problem was. So we analyzed this. We found out that the cooling loads in that specific space in the meeting room was that. Then we changed the curtain wall and we did this and this and that, and we reduced this by whatever. So that will be the final conclusion. What is the percentage of savings? So if this is your first analysis and this is your second analysis, the second analysis should be lower than the first one value. If it's higher, you have done something wrong, okay? And then what is the percentage? So we have to look at the difference between the first and the second. In this case, the difference is 4,000. We have to divide it by the original, the first one. And this is the percentage of savings from the third one to the second one. It's 20%. Okay, so that would be the final analysis. Then there will be another analysis, which is the economic analysis. Is it more expensive what you have done to reduce this? Actually, if we do something like that, if we replace some of the glass panels by some opaque panels with thermal insulation, it will be even cheaper because glass usually in curtain walls is more expensive than the opaque panel of the curtain wall. Okay, so we are not running economic analysis, but that would be the final stage, which is the economic analysis. Okay, so I have 20% of energy savings, but with 10% more of the money that we have to pay up front. And then there will be an economic analysis or about what is the payback period between the money that you pay up front and the savings, the energy savings that you have in the long term. But we are not doing that yet.
So within the conclusions, you want comparisons to like the building with negotiators and negotiators and showing the
Yeah, so the first option will be a curtain wall like this one. Okay, so in this curtain wall, we didn't do anything, it's just glass.
Yeah.
And then the second option, you have to do a curtain wall like that one, reducing the glass area, but without reducing the curtain wall area, and using some shading devices. And there will be different strategies for the south and the east and west curtain walls. Okay. And then it should work. If it doesn't work, probably there's something wrong in the Revit file, and we have to figure it out. So that's why I want you to do it on Wednesday, because if something goes wrong, I'll try to help you do it well. So that will be the first part of this report. Then there is more to that report. We have to run the thermal analysis of the envelope with Excel file and Therm. We have to work with the dew point analysis and with the Therm analysis in two details, the floor to wall and the roof to wall. You have already done this. So most of you did a good work using the floor or analyzing a transition, floor to wall transition. Now we have to analyze a roof to wall transition. We have to do this with the dew point analysis. So in the Excel file, we have to do the same. Okay, so you have to use the same elements that you have used in Revit. So here you have to show me all these layers in Revit. Then you have to do the same thing in the Excel file. We should have an R value that is similar to the Revit value. Okay, so if you have a wall in Revit that is 44, the Excel value should be close to 44. Remember that it depends on the thermal conductivity that we have here. You have some comments on the assignment that you submitted last week. The most common mistake is that in this table, you have selected the thermal conductivity for Revit units. So if in the, look at this, so it's like, if this is 4, this is 0.3. If this is 2, this is 0.2. Okay, so it's you divide this by 10. So if you make that mistake and you select the thermal insulation and you type here 0.02 instead of 0.2, you have a value here that it's insane, like 400 or 500. So be careful with that. Okay, so you have to select in this, for the Excel file, you have to select the values of this column. These are the values that we have in Revit. So we have this column with Revit because in Revit, if the thermal insulation, if the rigid insulation here in thermal is the thermal conductivity is 0.014 on the Excel file. Okay, so look at this. When we have a thermal insulation is 0.014. For example, this polystyrene. So here you have to type 0.17 for this one. Okay, so the insulation here would be 0.17. And now you have to adapt the thickness. It was 6 inches. So here we had 6 inches. And then the values would be similar. Okay, so it doesn't have to be exactly the same, but if the value in Revit is from 40 to 50, the value in the Excel file should be from 40 to 52. Okay. But here you have to include the vapor barriers. So I need to know that you know how to include the vapor barrier in the right side. And the value for this vapor barrier is, it has to be something very, okay, so I don't mind how many zeros you have here, but the goal is that this line has to drop below the level of the temperature so that there is no intersections between the temperature line and the dew temperature line. Okay, so it's just in Revit we can add a membrane. Okay, so remember that here we have a membrane layer with a vapor retarder. So here you don't have any thickness and it doesn't affect anything to the thermal resistance. But there is no way that we can test in Revit what happens when we add a vapor barrier in that position. Okay, but with this one, we can test it. So the next step, we have to, this is the geometry of the building and the first Revit analysis of the building. Then we need the thermal analysis of the building. We need the Excel screenshots for walls. Roofs and floor. And then we need the therm details. You remember that a few weeks ago, I posted like different floor to wall transitions. Then you picked one of the analyses, then you selected it. Okay, so now we have to do the same with the roof. So by Wednesday, I will post some roof to wall details. Here we have a flat roof. Okay, so probably I will post something like that, and then you will have to analyze the R value that we have in that corner. Okay, so we might have like different details. So I will post some of those with different materials and thicknesses, and then you will have to work with that detail in therm, and then you will have to analyze the R value that we have in this corner. We will try not to interrupt the thermal insulation. For example, this detail is quite that one. Okay, so in this detail, we have a thermal bridge because we have thermal insulation here. We have thermal insulation there, and we have thermal insulation here, and we don't have any thermal insulation in this corner. So there will be a huge thermal bridge here. So that's not a good detail. What we have to do is to try not to interrupt the thermal insulation. So that looks better because we have this thermal insulation here, we have this thermal insulation there, and we don't interrupt it. Okay, so that's it. We have to analyze the envelope with Excel and Therm. And I'm going to explain this because this is something that we can't do with Revit. We have to do it with the Excel file, the ventilation and infiltration, and the glass selection. We need to know the passive heat gains through windows. So that's something, that information, we have it in Revit, but I explained this very quickly last week, and I'll do it again, how to deal with this graphic. Okay, so we need the solar radiation from PV watts. Here we have to include the features of our glass, and here we can calculate the thermal loads and the thermal solar radiation through the window. Because the goal, it's something that we don't have in Revit. The goal with the Excel file is to get this monthly analysis. Okay, so in Revit, a few years ago, we could find this analysis in Revit very easily, the monthly analysis, but now I can find it. Okay, maybe it exists, but in none of the reports that I okay, it's not in the loads report. It's not in the detailed report. Here we have months, but this is not exactly what we need. This is the electricity consumption, electricity peak demand, but we don't have a thermal analysis for cooling and heating like that. Or maybe we have it in all this huge amount of information, but I haven't found it yet. Okay, anyway, we can do this with Excel, and we can do it with the design advisor. Okay, so here we have the monthly performance. We will try design advisor and Excel file for this performance. Okay. So this part of the report is not due this Friday. I don't have time today, so on Wednesday I will explain quickly how to deal with the ventilation and infiltration loads in the Excel file and the glass selection in the Excel file. And then next week I will explain this, the peak heating loads. Well, basically, this is a summary. This is what we get from Revit, and this is what we get from Design Advisor in the Excel file, and then result and conclusion. Okay, so I will explain this point number 6, which is the monthly performance. So you can do everything that is here this week, except this monthly performance analysis. So on